Okay, so we need to talk for a minute about something that's called dispersion, the dispersion of light. We know that light travels in a vacuum at a speed of 2.9979 times 10 to the 8th meters per second. We also know that light, there's a whole spectrum of light. Well, what we've discovered, whoops, this is really C. What we've discovered is that all types of light, everything in the spectrum travels at 2.9979 times 10 to the 8th meters per second in a vacuum. But when it enters another medium, all those types of light slow down, but they all slow down at different rates. So in other media, red light travels at a different speed than blue light, than green light, than purple light. It means that the index of refraction for all the different types of light, colors of light, is different. So what dispersion is the spreading out of white light into its colored spectrum. And it happens because they all travel at different speeds, right? So we have a beam of white light coming in and striking a prism. Well, then that white light is going to get separated into its different colors because they all are going to bend a different amount because they all travel different speeds. And so when they come out on the other side, they're not going to all come out at the same spot. Instead, there's going to be red on the top. It's going to bend the least, and then orange, and then yellow, all the way down to violet. What we get on the other side is a rainbow. Okay? And it's because red travels fastest in in another medium other than a vacuum than violet does. So red bends the least. It always, always, always ends up on top. So when you look at a rainbow, the colors of the rainbow are happening because of the fact that light was traveling through a vacuum or through air and then encountered water droplets. And so as that white light entered the water droplets, each of the different colors slowed down a different amount, and so they dispersed. They were spread out when they came out. So dispersion is the spreading out then of the white light, the separating of the white light into its component colors when it enters another medium. Okay, the separation of white light into its colored spectrum, really. Okay. So it happens in the rainbow and that's why there always has to be sun out and rain. It also happens if you have any of those little glass prisms hanging in your window. My mom has all kinds at home in her window, and so there's rainbows all over the floor because the white light enters the prism, the glass prism, at an angle, and it gets separated into its component colors. Okay, so that's the dispersion of light. The one other thing that I want to start to talk about today, and we'll finish it tomorrow, is a term that we've already learned about, diffraction. If you remember from when we first started waves, we said diffraction was the spreading out of a wave beyond a barrier or around a corner. Okay? If you put a barrier up in your bathroom, in your bathtub, 2 blocks of some kind, and then you tapped your finger here, the wave fronts would get to this little opening and they'd pass through the opening and then they would spread out like this, as if this was the new source. Okay? Waves can also go around a corner. So if I had a block here and I was making straight waves, these wave fronts would come down here, and when they got to the edge, they would curve around the edge. I don't know how to show it. So they would curve. I can't do it in this picture. Shoot. Let me make them travel this way, and then maybe I can. So if I put the the edge here. As they're coming here, they're going to curve this way around this edge, almost as if the edge is a source itself. So let me see. Yeah, there we go. I can do it backwards. Sorry, that was just upside down for me. Okay, now how much something diffracts, the degree of diffraction depends upon the wavelength of the wave and the width of the slit that it's going through. Okay, and so diffraction not only happens with water waves or sound waves, it happens with light as well. And if there are two openings, right? If you're in the bathtub again, and instead of just doing one opening, if you did two openings and then you moved your finger up and down here, you will get the spurting out of waves behind both openings, and you will get that diffraction pattern that I drew for you the other day, where you'll get constructive and destructive interference. So this pattern is a result of diffraction and interference, right? So the waves are spurting out behind the barrier and then they're interfering with each other. Okay? Now when this happens, we had talked the other day about the fact that you will get bright spots if it's light, loud sounds if it's sound, but today we're using light. You'll get bright spots here. Bright spots will occur if there's a whole number of wavelengths along this path, right? So you need two sources that are coherent, two sources that are in phase with each other. You need for light, the sources can't be too far apart. And the path difference from one source to the other, I need a different color. Oh, maybe I can use, that's blue, I can use back. So if we were to draw a line from this source to this bright spot, and this source to this bright spot, the difference in the path, the length of the path, has to be a whole number of wavelengths, right? So that when they get to this spot, they're in phase with each other, and then there'd be constructive interference. If it's only a half number or an odd number of half wavelengths, or less than a wavelength, it's going to be destructive interference, and it'll be a dark spot. So each of these spots is a spot where constructive interference is happening. Okay, this experiment is actually quite famous. It's called the Young's double slit experiment, and it was done by Thomas Young back like right around 1800, so a long time ago. These bright spots are called bright spots. Sometimes they are also called fringes. Fringes or bright spots. Okay. And they are the spots of constructive interference. The other spots are the spots of destructive interference. Now, we can derive an equation, but I might actually wait and do it tomorrow. We'll come back to the equation tomorrow. So for right now, diffraction, the spreading out of a wave beyond a barrier, and if there are two openings that it can spread out, then you'll get diffraction and interference, and you'll get this, what's known as a diffraction interference pattern on, if you remember, this was a screen that we had placed back here. Okay, we'll come back to this tomorrow and we'll derive an equation. So tonight's work will be with critical angle and total internal reflection.